Bismillahirrahmanirrahim. Assalamualaikum and hello everybody. Welcome once again to the distinguished lecture series brought to you specially from Faculty of Engineering, Universiti Teknologi Malaysia. I'm Jay Suman from the School of Biomedical Engineering and Health Sciences, Faculty of Engineering, and I will be the chairman for today's session. So ladies and gentlemen, the distinguished lecture series will actually present to you right at your screen groundbreaking discoveries, astonishing findings, and experience sharing from prominent scientists, scholars from around the globe. So, ladies and gentlemen, take this opportunity, feel free to post your questions and comments at the comment section at the live session you're watching right now in YouTube and also at the Facebook section. So, I'm sure you already know who will be our special guest for today's session. So, I'm not going to be the spoiler over here. Without further delay, I will turn the time over to the Dean of Faculty of Engineering, Universiti Teknologi Malaysia, Professor Engineer Dr. Muhammad Rafiq Abdul Qadir for the opening remark. How are you, Dato?
Thank you. Thank you very much, Jai Suman. Assalamualaikum and hello. Welcome everyone. Welcome to UTM Engineering Distinguished Lecture Series, our fourth lecture in this series. My name is Muhammad Rafiq and I am the Dean of Engineering, Universiti Teknologi Malaysia. Today, it is my utmost pleasure to welcome Prof. Jean-Marc Linares to our program.
Hello.
Professor Linares is a full professor at Aix-Marseilles University, France, and a research team leader of bio-inspired design at the Institute of Movement Science Laboratory. His research interests include bio-inspiration, biomechanics, and mechanics in general. Prof. Linares is currently the president of French University National Council in the field of fluid mechanics, solid mechanics, material mechanics, mechanical engineering, civil engineering, and industrial engineering. He is also involved in the management of promotions and bonuses of around 2,500 pupils in French laboratories. Prof. Linares is a university leader of the Bio-Inspired Mechanics Chair with 500,000 euros over 5 years. He is also the Airbus Helicopters AMU Excellence Chair in Bio-Inspired Design. Without further ado, I call upon Prof. Jean-Marc Linares for his talk. Over to you, Prof.
Okay. Thank you, Professor Rafiq, for this nice introduction. Mr. Chairman, ladies and gentlemen, I have the honor of presenting you a reflection of the current situation of COVID. The aim of this talk is to demonstrate the role played by the additive manufacturing technology to quickly release products to protect the people when the classical process of production was not able to answer to the need imposed by this pandemic. Okay, now what is interesting in this slide is the schedule of this talk. The first, I propose you to talk of the history of the pandemics. Second, to discuss on the main vector of propagation of the COVID. And third, we propose you to illustrate the use of the additive manufacturing to produce COVID protection. I will finish this presentation by the classical conclusion. If you look at this slide, you can see this figure here, where the past pandemic are classified. You can see here, here the set of power of this pandemic: low, moderate, high, and very high severity. These pandemic are classified by the clinical severity and its transmissibility. This figure can be uploaded using these website links. In this study, the pandemic of the First World War is located here in the top corner of this picture. This pandemic has been the deadliest we have ever seen. In comparison with the pandemic of 1968, is positioned here. This pandemic is very interesting because at this date, I am 6 years old, and this event is in my memory because I remember my both parents have been sick, and my father had a very strong flu. This flu caused in France 13,000 of dead during 2 months and around 1 million of dead in the world. At that time, no precaution, no preventive action were taken to stop this epidemic. No quarantine, no health recommendation, etc., as the case of the COVID. The French government take preventive action. In this case, in this moment, for example, in France, in June of this year, the France have around 29,000 dead in 4 or 5 months. In the world, around 400,000 deaths. Now we are presented the pandemic history. We propose you to focus this on the main vector of COVID propagation. If you look at this slide, you can see some experiment here about the main propagation of the flu. The main vector is a droplet. You can see here some droplet, and here the trajectory of each droplet. The virus is transmitted primarily through droplet produced when an infected person coughs, sneezes, or exhales. These droplets are to be heavy to stay in the air and fall quickly. You can become infected by breathing in the virus if you are near a sick person or by touching the contaminated surfaces, and then touching your eye, your nose, or your mouth. You can see at this picture here, you can see the distance when the droplet travel in the air. In this experiment, this distance is around 0.7 meters. In the next slide, I propose you to use the fluid mechanics equation to estimate this distance. During the French quarantine, my colleague Philippe Gondry of the Paris-Saclay University sent me this calculation. This calculation permits to explain this preventive recommendation of the French population. To estimate the distance the distance traveled by the droplet, we use this data. You can see here this data. The diameter of the droplet was taken equal to 1 millimeter. The initial speed of the droplet after its emission by the mouth is 1 meter per second. The dynamic of this phenomenon was taken as an inertial fluid regime, where the Reynolds number is greater than the number 1, in this case 40. property. The calculation of the speed during the time with an inertial growth forces gives the characteristic deceleration distance. You can see here the equation of this inertial drag force, and here the characteristic deceleration distance derived with this equation. In this equation, the rho droplet are the density of the droplet, and the rho air is the density of the air. With this data, is possible to calculate when we take, with this data, and we take the drag coefficient equal to 1, we obtain 1 meter for this distance. This distance represents the minimum distance between two persons to no propagation of the COVID virus. In the next slide, I present you some public documents made by the French government. What's interesting in this slide is a part of public documents made by the French government. You can see here the secure distance of 1 meter between two persons and another measure. You can upload this document. These documents are in English language. It's possible to upload this document using this web link. Now we have defined the main process of the virus spray, we will look at the dynamic of the pandemic. If you look at this slide, you can see the picture of the pandemic. You can see here the pandemic without measure to stop the propagation, and this Gaussian law we represent the picture when we have take measure to stop the propagation of the virus. The basis of this picture as of sources the Lancet. You can see here the sources of this, the basis of this picture. In abscess of this picture, the unit is the time, and the other direction, the number of COVID cases confirmed. Without preventive action, the pandemic take an Gaussian law PDF with a very high speed of propagation compared to the propagation speed when we take protective measure. You remember the case of the flu of 1968, where preventive action don't take. We have 32,000 dead in 2 months, numerous more dead in 2 months. In this COVID pandemic, the French government take hard preventive action to reduce the propagation of the COVID, and this was taken to don't reach the capacity limit of the hospital service. So for this, it is a principal reason of the use of preventive action, of this preventive action. To take now when we have in the beginning of the pandemic, we have little time to protect the people and increases your hospital capacity. And the make product with additive manufacturing technology permit to produce product for the people and the hospital. It has allowed to answer very quickly to the hospital first needs, after industry has taken the relay. It is the aim of this presentation, the use of additive manufacturing in COVID situation. In the next slide, I propose you to focus on this technology. If you look at this slide, you can see the picture published in the CRP Annal in 2017. The publication reference is written here. It describes the link between the part complexity in abscess and the cost of the produced part. In red color, you can see the cost of the part when we used conventional manufacturing. In blue color, the cost of the part when we use additive manufacturing. It's allow to analyze the cost of the part is when we use additive manufacturing is independent to the complexity of the part. It is a very good property of the manufacturing, the additive manufacturing technology. In the next slide, we focus on the democratization of the use of the polymer additive manufacturing. What is interesting in this slide is the sources of the democratization of the polymer additive manufacturing technology. The first is the price of the 3D printer. During the price of this equipment was divided by 10 during 15 years. Second, the price of the material was same divided by 7.5 during the same period. And finally, numerous free 3D printing software are present in the web. During the COVID crisis, Aix-Marseilles University used around 100 additive manufacturing machines to answer to the local hospital needs. Now, after to introduce this technology, we subject you to present some case where the additive manufacturing was used during the COVID crisis. The aim of this slide is to present the transformation of the Decathlon swimming mask in respiratory mask using additive manufacturing technology. The Italian was the first to employ this mask to help patients with respiratory difficulties. The movie, you can see here the movie, this movie represents the use of the respiratory mask in the Belgian hospital to help the patient with respiratory difficulties. In the left bottom of this slide, you can see the use of the Decathlon mask for protect the staff of the Nantes hospital in France. In the right bottom, here and here and here, you can see the respiratory valve and the connection made using additive manufacturing. These parts are made by an Italian startup. Now, if you look at this slide, you can see the protective visor made by Polymer additive manufacturing. This equipment was manufactured to protect hospital staff and workers in contact with COVID patients at the start of the pandemic. You can upload STL file using this website, this link, these web links. This slide summarizes another equipment is a door opener. You can see here in the movie the use of these devices. It's allowed to isolate the user hand of the contaminated surfaces. You can upload here the STL file of this part in this website. Now we focus on this slide on the medical ventilator. You can see here the electronic equipment and here the part of the respirator. This slide focused on, about the medical ventilator. It is an emergency artificial respirator device that is cheap and easily reproducible. This project is a humanistic and disinterested initiative was only vocation to preserve life by offering the response of the lack of material related to the current crisis. This ventilator is free, usable by everyone, everywhere in the world. You can see the document of this respirator at this web link. What is interesting in this slide is the procedure to disinfect for the disinfection of the part products by 3D printing. The first is the peri-hospital regular disinfection procedure. This procedure is very easy to use because it uses a classical active chlorine. The second is the Marseille Hospital procedure and is use specific product. You can see here is Annual Clean XLD product. This procedure can be only used by hospital or structure that have access to these medical hygiene products. Now we go to the conclusion. This sanitary crisis has highlighted numerous new mechanisms in the French people. I bring to the fore the need of the fast answer to fight the COVID propagation, to free humanistic and disinterested initiative to stop the pandemic. It's necessary to organize this initiative. For example, more than 10 different models of protective visor were designed and manufactured for France. For example, necessary, to reduce this number, necessary to organize this initiative. After this crisis, bring to the fore the search of new solution to compensate for the lack of vital product, for example, the medical ventilator. And necessary after to quick consider the need of the front line in the war against the COVID. I think for the doctor and the nurse is the first line of the war. necessary to take into account the comfort of the use of this product, the disinfection operation. So, to conclude, the additive manufacturing was a good technological support for fight against COVID. It has allowed to answer very quickly to hospital first need after the industry has taken the relay. Thank you very much for your attention.
Okay, thank you very much, Professor Jean-Marc Linares. That was an amazing presentation. So ladies and gentlemen, for those of you just joining us, welcome once again. Selamat datang. And please feel free to post your questions at the comment section, at the live session right now. Either it's from the YouTube or from the Facebook. So it's time for question and answers. We will go ahead and take some time for this session. Should we come up with the first question if we have from the floor, the virtual floor? That was the presentation. If you can see, what was presented by Prof. Linares is actually something that a wonderful initiative taken by Prof. and the university as well. It was actually that the first main point is also is to assist the frontliners working so hard right in front for the security for the whole nation. So I was quite interested actually, Prof. Linares, from the very first slide when you show the 3D printing of the face shield, shield, because you have it there.
We have here
wow.
some product because we have numerous model. This one is a visor to protect the eyes, and the mouth to the projection of droplet. You can see here the first model. Oh, sorry. And the one. And the second model is Europe model. This one is the name of the field, of the field format. And this one is another model. We have the complete to put directly on the head to protect the person.
So the frontliners are using the 3 types of models, right?
Yeah. And this one is manufactured directly by the 3D printing, polymer 3D printing.
You mentioned something in the conclusion that I think. Okay, yeah, we have a question now. Okay, let's go with the question. Our priority to the crowd. Yeah. So the question from Prof. Nur Hazila and Mohammed Noor, the question to Prof. Do you think 3D printing industry will progress to a new level due to the pandemic? Prof. Linares.
I think the 3D printing was developed and democratized before the pandemic, and the manufacturing is allowed to develop quickly new product to fight the COVID. The 3D printing industry will progress before the crisis. I think I answer to this question. I think.
Indeed, actually, 3D printing industry really comes in really handy, especially during the ambush of COVID-19. Everything just happened just over the night, and production industries all have to be shut down just without any prior warning. So 3D printing was actually one of the printing industry that really helps out a lot in the world, especially. So coming back to the face shield, I was quite interested, Prof. Linares, because I was one of the team members to actually print out those material as well. And you mentioned about disinfection. So how did you carry out the disinfection for those 3D printing face shield before you supply or you hand it over to the frontliners?
Wow.
You mentioned about using the active chlorine for disinfection.
Yeah. It's possible to see the slide?
You want to show the slide? Yes.
Okay. I go to the
Yeah, that was it. Yeah.
Sorry.
Do we have Prof in the line? Do we have Prof Linares on the line? Our connection got infected, right? Well, okay. So yeah, he was actually, while we are waiting for him to re-enter back the broadcast room. So this is actually related to 3D printing. And I'm sure most of us in the engineering field, especially, we are all
we are
pretty much involved.
Yeah.
Yes, Prof. Yeah.
Yeah.
Is it okay?
Yeah. I share my screen. Sorry.
Yeah, please proceed.
Problems. Okay. Okay, you see the slide now. Okay. The first procedure is very easy because we use the classical blanch. Okay, it's not necessary to buy this specific product, and this one is very easy to disinfection your product. And the one, for example, you put in the water with 1 volume of blanch, and this permits to disinfect your product.
So users can actually do the disinfection process by themselves if they have all the materials, right?
Yeah. It's very easy. This one is very easy, and this one is professional procedure. This one for Marseille Hospital disinfection.
And we have another question from Azlin Abdul Jamil, Prof Linares. The question is, what is the difference between face mask and respirator? And what is the difference between face shield in terms of effectiveness? That's interesting. Prof, would you like to respond to that?
Okay. So this one is to help the patient to respire and sorry. This one is only the mask to transmit the air to the patient, and this one, but to produce the pressure to the air necessary to use the respirator. The respirator produce the air we arrive here. Okay. The mask is only to put on the face of the patient, and this permits to the patient to respire. Okay, and this one creates the pressure of the air. Okay, the respirator is to make the pressure of the air, and the mask to permit to the patient to respire. It's okay. And after, oh sorry, and this one, no here, where here? Oh, where is the slide? Okay, this one, and this one, the protection is a protective visor, is only to stop the droplet. This one is only to stop the droplet of the. Okay, it's only to stop the droplet. It's not for respiratory. This one. It's okay.
Linares, sorry.
Yeah. Yes,
just an additional to the question just now. So we were talking about disinfection of these 3D printing materials. Now, how do we deal with the disposal of these materials? You know, when the front liners, they've been using all these things, it has to be disposal because they will be using it every day on the new units, right? So how do you, or in a place in France, how do they manage these disposals?
I don't know the number of the, for example, for the universal respirator, I don't know the number. For the visor, for my university, each week we produce around 2,000 visor for the local hospital of Marseille.
That's a lot, Prof.
Yes.
That's a lot.
And in each country of France, as France are numerous country in France, in the national country, each local country produce visor and so on. Each university or school of engineer produce for local hospital visor and so on.
Right. Okay, great. Ladies and gentlemen, should we take the last final question before we end our session today? Do we have a last question from the floor? Or else we will be calling off for today's session. Well, okay, that's great. So, Prof. Linares, it's been a pleasure and honor for me to be the chair for your wonderful presentation this evening, Prof. And it's morning in France, right? It's morning in France. Yeah. Anyway, so thank you very much once again, Prof. Linares. And I will turn back the time to Professor Rafiq, the Dean of Faculty of Engineering, Universiti Teknologi Malaysia.
Thank you, Jaisuman. Thank you very much. And to Prof. Jean-Marc Linares, our deepest gratitude to you for sharing your knowledge with all of us. Thank you so much. And to all of you watching this program throughout the globe, and we have our viewers from Europe, the Middle East, and of course in Asia, Southeast Asia, don't forget to like our Facebook page because we have many more interesting lectures for you. And do share this video to all your friends and colleagues worldwide. Thank you for watching. I'll see all of you in our next episode of UTM Engineering Distinguished Lecture Series. Bye for now.
Okay, bye-bye.